Welcome to Lesson 4 of our Cyber Safety series in ELN 260, Integrating Physical and Digital Safety. In this lesson, we will look at how cybersecurity and physical safety work together in industrial environments. As control systems become more connected, it is important to understand that digital problems can affect physical equipment, safety devices, and worker protection. In other words, cyber safety is not only about information or networks, it is also about protecting people and machines. To begin, let's think about the real-world consequences of a digital problem affecting a safety system. Think about this. What could happen if a cyber attack or unauthorized change disabled a safety relay or bypassed an interlock in a control system? Industrial control systems rely on both physical safety devices and digital control logic. If the digital system controlling those devices is compromised, the equipment designed to protect workers and machines may no longer function as intended. This shows why physical safety and digital safety cannot be treated as separate issues. Now, let's look at the main objective for this lesson. This lesson explores how digital threats can affect physical safety systems used in industrial control environments. We will examine how cybersecurity issues could interfere with safety relays, interlocks, and other protective devices. Understanding the connection between digital systems and physical safety supports ELN 260's focus on designing reliable control systems that protect both people and equipment. Let's begin with the physical safety side of industrial systems. Industrial systems rely on physical safety components such as emergency stop buttons, safety relays, interlocks, guards, and protective sensors. These devices are designed to detect unsafe conditions and immediately stop equipment or prevent the dangerous operation of machines. They are a key part of protecting workers, equipment, and the production environment. Modern systems also depend heavily on digital control. Modern control systems often use PLCs, networked I/O, HMIs, and industrial networks to monitor and control equipment. These technologies improve automation and efficiency, but they also create new paths where digital problems can affect physical operations. The same systems that help machines run smoothly can also introduce risk if they are not protected. That brings us to the connection between digital control and physical safety. Many safety systems now interact with programmable controllers or networked monitoring systems. If software settings, communication signals, or controller logic are altered, the system may behave differently than intended. A change in the digital system may not be obvious at first, but it can still affect how physical equipment responds. This is why engineers and technicians must think about both the digital and physical sides of safety. Let's take a closer look at one of the key physical safety devices, safety relays. Safety relays are devices designed to monitor safety circuits and ensure machines stop when unsafe conditions occur. They verify signals from emergency stops, guard switches, and safety sensors before allowing equipment to operate. In many systems, safety relays serve as a critical checkpoint between safe and unsafe operation. Another important protection is the interlock. Interlocks are safety mechanisms that prevent machines from operating when protective conditions are not met. For example, a machine may not start if a safety gate is open or a guard is removed. Interlocks help ensure safe operation during both maintenance and production. They are designed to prevent dangerous conditions before they occur. Now let's look at how cyber threats could interfere with these safety systems. Cyber threats could potentially interfere with safety systems if attackers gain access to the control network. This could involve modifying PLC logic, altering configuration settings, disabling alarms, or interfering with communications between safety devices. When that happens, the physical safety system may no longer respond the way it was designed to. That is why digital security plays such an important role in physical protection. Examples of the kinds of risks that can result. Examples of possible risks include disabling safety alarms, bypassing interlocks through software changes, sending false signals to safety devices, or altering PLC logic that controls safety responses. These situations can create dangerous conditions for operators and equipment. Even if the physical safety hardware is still in place, digital interference can prevent it from working correctly. Let's look at a real-world example called Triton, which is also known as Trisys or Hatman. This malware is important because it was designed to target Schneider Electric Triconnect safety controllers. These controllers are part of a Safety Instrumented System, or SIS, which helps bring industrial equipment to a safe shutdown state during dangerous conditions. In the 2017 incident, attackers gained access to a petrochemical facility and deployed Triton against the plant's safety system. According to U.S. government reporting, the malware modified controller memory and was designed to interfere with how the safety system operated. This means the attack was not only against a computer or a network, it was aimed at the part of the system responsible for helping protect people, equipment, and the facility itself. This example is important because it shows how a cyber attack can become a physical safety issue. If a safety system does not respond correctly during a dangerous condition, the consequences could be very serious. In this case, the affected system moved into a safe state after the controllers detected a problem, which helped prevent the incident from becoming worse. The main lesson from Triton is that physical safety and cybersecurity are closely connected. Protecting safety controllers, limiting access, monitoring for unusual activity, and securing both IT and OT networks are all important parts of keeping industrial systems safe and reliable. These examples show why safety systems must be designed and protected carefully. Good industrial control design separates safety functions from normal control operations when possible. Dedicated safety circuits, properly designed control logic, and clear system architecture help maintain reliable safety performance. A well-designed system makes it easier to protect safety functions and reduces the chance that a digital problem will interfere with physical protection. That design work must also include protection for the digital system. Protecting the digital system helps protect the physical safety system. This includes limiting access to controllers, controlling programming privileges, monitoring network activity, and keeping systems updated and properly configured. These practices reduce the chance that someone can make unauthorized changes or interfere with the system's safety functions. Monitoring also plays an important role. Monitoring control systems helps identify unusual activity before it becomes a safety issue. Alerts, logs, and system monitoring tools can help detect unexpected changes, unauthorized access, or abnormal system behavior. Good monitoring allows teams to respond more quickly and reduce the chance that a cyber issue will become a physical safety problem. All of this supports one larger goal: safe and reliable operation. Reliable industrial systems depend on both physical safety design and secure digital control. Engineers and technicians must consider how network connections, software changes, and device communication may affect safety performance. If the digital side of the system is not protected, physical safety functions may not work as intended. In modern industrial environments, safety and reliability depend on both good design and good cybersecurity practices. That leads directly into the safe design practices teams should apply. Safe system design includes documenting safety circuits, verifying control logic, testing safety devices regularly, and limiting who can modify system settings. These practices help maintain both operational reliability and worker safety. When safety systems are documented, tested, and protected, teams can trust them more and respond more effectively when issues arise. Before we wrap up, let's reinforce the connection between physical and digital safety. Physical and digital safety work together in modern industrial environments. Protecting control systems from digital threats helps ensure that safety relays, interlocks, and other protective devices continue to function correctly. When digital systems are secure, people are better protected, equipment is more reliable, safety devices work as intended, and operations are safer and more stable. Physical safety depends on digital security more than ever before. That brings us to the main idea you should remember from this lesson. The key takeaway from this lesson is that physical safety and cybersecurity are closely connected. Protecting control systems from digital threats helps maintain the proper function of safety devices and supports safer operation across the entire industrial system. In modern control environments, strong safety design must include strong cybersecurity practices. Before we close, let's summarize the lesson. In this lesson, you examined how digital threats can affect physical safety systems, how safety relays and interlocks support protection, and how design, monitoring, and cybersecurity practices help maintain safe industrial operation. Together, these ideas show that digital security is an important part of physical safety in modern industrial environments. Now, let's close the lesson. You have now completed Lesson 4 on integrating physical and digital safety. As you continue through the course, remember that safe control systems depend on both strong physical design and secure digital control. Protecting people and equipment requires attention to both sides of the system. Thank you for completing this lesson. Keep these ideas in mind as you work with PLC systems because safe industrial control depends on both cybersecurity awareness and sound physical safety practices.